Okay, so I'm going to do a Grok talk here on optimizing stored procedures and trying to make your recompilations happen when they should happen and not happen when they shouldn't. My name is Kimberly Tripp. I am an RD in Redmond, Washington, and I've been working with SQL Server since 1990. Started when I was 12, and for the last 10 years I've been doing training, consulting, speaking at conferences like TechEd, and you know what? I really like the technology. You can read about all the good stuff on the blog and on my website, and I will post the demo scripts that I do today on SQL Skills so that you can reproduce this in both SQL 2000 and 2005. So, I do have slides. I lied on my abstract saying that I wouldn't have slides, but I have slides just to go through really quickly so that I can make some basic principles known, and then I'm going to spend the rest of the time in demos. So when it comes to stored procedure processing, when you create that stored procedure, there are certain things that happen. When you execute that stored procedure, there are certain things that happen. And getting some good insight into what happens when is really critical in trying to make those stored procedures optimal long term. So we're going to start out with an overview on processing stored procedures. Then we're going to look at recompilation issues, when you should actually recompile and force recompilation. This is a pretty common slide. A lot of people have seen this. When a stored procedure is created, that stored procedure goes through parsing and resolution. Those are always going to occur. Resolution essentially allows the system tables to be populated with information about dependencies if the objects on which the stored procedure depends exist. They will re-resolve at execution, and if an object gets dropped that a stored procedure depends on, then SQL Server will recompile the stored procedure, and that makes sense. So what we have to know is, when doesn't a stored procedure get recompiled? And you will find that just different parameters being passed into a stored procedure aren't enough when in many cases they should be. So let's actually look at that. Recompilation is a process of optimization, and optimization is recompilation. So getting a good feel for when you should recompile is really critical. So that's really the thing that I don't see documented very often, and I see a lot of people fumble on. So when do you want to recompile? How do you know that you want to recompile? And what are the different options that are available for recompilation? So the reason why you might want to recompile is that if you don't recompile, then you can end up executing a stored procedure that has an already saved plan that is not optimal. And the cost of recompilation may be significantly less than executing that stored procedure with a bad plan. So you need to look at when it is appropriate. Now, I'm not going to tell you to do this for every single stored procedure, but it's kind of an 80-20 rule. Look at 20% of your problem, the top 20 worst performing stored procedures, and then if you optimize those, it is very likely to, in many cases, solve 80% of your problem. So, faster execution with a better plan can often yield much better results. Some plans, in fact, should never be saved. So, last slide, and then I'm going to start doing some demos. If you look at a stored procedure and its plan does not seem optimal, meaning it has different performance execution, sometimes it seems fast, sometimes it doesn't seem fast, then what you can look at is multiple different options for how you recompile. You can create that stored procedure in such a way that it is always recompiled. You can execute it with recompile so that just that execution is recompiled. You can force a recompilation with SP recompile, which just says right now recompile it, and then that plan stays in cache from that point forward. Or you can do some form of statement-based recompilation, and this is something that differs between SQL 2000 and SQL 2005. So I'm going to do my demos on SQL 2000, but I'm going to give you some insight into what works in 2000 versus 2005. So the tool I'm going to use is Management Studio. Management Studio is the replacement for Query Analyzer and Enterprise Manager in Yukon, and the script that I'm going to use is called Recompilation Issues. Now, my real estate isn't very good with 8x6, so I'm going to try to make this as viewable as possible. In fact, you know what? I'm going to change my options. I am running against SQL Server IDW 14, which is the April CTP. Just today, they released IDW 15. I don't expect any changes from what I have here, but obviously a little bit of testing is going to be warranted. I'm going to use a database called Credit. This database is downloadable on my website, and I'm going to make a couple of updates to some rows so that I have rows that I can search on. So I'm going to make a change to the data so that, and I always do that, a change to the data so that I have a row named Tripp here, and I have modified a row that I will later search on, and right here I'm going to check my indexes, and of course I'm not in the right database, really quickly. Check my indexes, and you can see right now that I don't have an index on last name. An index on last name would make searching by last name a lot more effective. So I'm going to create an index here on last name, and I am going to go ahead and end up creating a stored procedure. Very simply, you pass in a last name, you run a select that uses a wildcard parameter here to pass in the last name, and it could be a quality, it could be a wildcard. I'm using a like condition, so that gives us flexibility. So I create this stored procedure, and you can see that there's a variety of different types of executions. To end up seeing what's happening in that stored procedure, I'm going to turn statistics IO on and something called show plan on. Now, show plan is turned on with a keystroke, Control K, which I've shown here, or you can go over to Query, Include Actual Execution Plan, and this will allow me to see what is being chosen during the execution of these stored procedures. So I'm going to execute my get member info with Tripp, run this, end up seeing the, give it a second here, after it executes, it generates the execution plan. Now, this may look a little more complicated than it is, but they're basically using my last name index to end up seeing what the particular last name value is that I passed in. They take what's called the row identifier, they give that over to the clustered index, and then that returns it to the client. So that's this part that's doing the index seek, and this is doing the data lookup, the clustered index seek, and the join is essentially joining those two values together. So that looks pretty good, and in terms of IOs, it only cost us 6 IOs to actually read that data. That's not very expensive at all. I ran this for T% because remember I used like so I can pass in wildcards, and T% is obviously not nearly as selective. 386 rows are returned. My execution plan, however, has not changed. It's still using the index on last name, and then it's doing effectively what we call in 2000 a bookmark lookup. Unfortunately, this isn't really a great plan, especially if we look at our IOs. It's now at 776. If I go back here and I do something even worse, %T%, I mean, imagine looking at the phone book and saying, I need to find everybody that has a last name that has an E in it. You'd literally have to read row by row, flipping page by page through the entire data set. Now, since the plan has already been dictated to grab the values from the non-clustered and do the bookmark lookups into the clustered, unfortunately, that's the plan that's going to be chosen here as well. So it turns out we do the index seek, we go do the clustered index bookmark lookup, and then we go over and we do 5,407 IOs. If we did a table scan at this point, it would only cost us like 143. So the point that I'm making is that all of the plans are exactly the same, right? You're actually generating exactly the same plan for each execution because the plan was chosen by the first execution. So what I would start wondering is, I wonder if that's really an optimal plan. 5,407 IOs doesn't really seem optimal to me for something that should have done a table scan. There's only 10,000 rows. Now, I do mention here I could do an SP recompile to say get rid of the plan and try it again, but that means whatever plan they choose would then get used for everybody else after that. So something that I do often, and this works in 2000, it doesn't work in IDW 14, but it will work in 15. If you say execute with recompile, you'll get a new plan for each execution. And what you can end up doing is comparing the plans for each of these executions to see if they are optimal. Now, I think, and let me test this again, in IDW 14, I end up getting the same plan, and I don't get a new plan recompiled. So this is actually a bug that's been fixed in 15. I just wanted to make sure. So something I can do to make it get recompiled for every execution is I can alter the procedure with recompile right here, alter the procedure with recompile, so every execution gets recompiled. And by doing that, then each execution, instead of it saving a plan and reusing that plan, I'll get the optimal plan for each execution. So now, I run this, and I see that the first one was 3%, the second one was 48, and the third one was 48, but if you look at those plans, they're also the same, so that kind of makes sense. The thing that you should notice from this, though, is that the 3 plans are not consistent. So that immediately tells me that the parameters being passed in, when they generate the plan, the optimal plan varies for each execution. That tells me that I don't necessarily want to save the plan. So now I have to decide what I want to do to that stored procedure. If it's a little tiny stored procedure like this one, you could do exactly what I just did right here, create it with recompile so that every execution gets its own plan. But the problem is, some of you, maybe one or two, have stored procedures that are maybe 300 or 400 lines of code instead of 4 or 5 lines of code like I have here. And the problem then is that you have this one offending line of code and the rest of the stored procedure is really fairly consistent. So instead of having 400 lines of code being recompiled on every execution, you want to just take this offending statement out, have it recompile, and then not have to worry. So in SQL 2000, there is no way to do statement-based recompilation. My recommendation, okay, one way, not a great way, is to use dynamic string execution. But don't worry, I don't have to spend any time here because this is prone to all sorts of other problems. But generally speaking, if you do have a statement that's dynamically executed, it will probably get recompiled and it'll probably get a special and new plan. But that's a bad choice because of all sorts of other issues. SQL 2005, however, so if my statement is exactly the same as what I had before, select star from last name where last name like last name option recompile, this is a 2005 feature, that is statement-based recompilation inside the bounds of your code. Now this is very cool. The problem is it's SQL 2005. So now the next question would be, what could you do in SQL 2000 to get this to be more optimal? And basically, it's a very simple approach. You have to modularize your stored procedures. You have to break down those 400 lines of code, monolithic stored procedures that do 400 things in them, into potentially 2 or 3 or 4 stored procedures, taking the offending line of code out, putting it into its own sub-procedure, and then controlling the recompilation behavior on just that small, more modularized code. So I have another script. I always have a script. Another script that allows you to start seeing the benefits of modularization. So this one also runs against the credit database. And just a quick check on my indexes. We already know the indexes that we have. I'm actually running a full-blown SP help instead of an SP help index here. So we run a help index. We've got the index on last name. I've got a few more rows maybe modified here to mess with. And then I will go ahead and I will create a stored procedure, and this is kind of interesting, that uses conditional logic. The reason I do this one first instead of modularizing is even somebody yesterday told me, oh, but if you just put it into an if statement and say, if there's a wildcard, do one thing, otherwise do something else. SQL Server optimizes the process of optimization by optimizing even those statements that don't get executed. So even when you have conditional logic, if the else condition is what gets executed, the if condition gets optimized as well, sometimes resulting in an inoptimal plan. So if you use conditional logic like this may not be beneficial. I'm going to drop and recreate my get member number and turn it into 2 conditions. If there's a wildcard, use the first select. Otherwise, use the second select. And notice I'm going to go with Tripp here, which is going to use the second select. So I'm switching to text-based results so that we can see the message that I'm outputting as well as the data being produced as well as the IOs that I've asked for. So I've used the second select, I see the IOs, and if I turn on show plan and I execute it again, we'll end up seeing the same plan that we saw before, which is to use the index to do the bookmark lookup and return the results. All of that sounds good when we're passing in something that's highly selective. But instead, I'm going to go to T%, which we know is going to be the first if condition, not the else condition. And yet, when we run it, it seems pretty fast. There's not that much data. But if I go to the very end where it shows the IOs, we'll end up seeing that the number of IOs is only, 781, which a table scan would have been like 140. If I go look at the execution plan, it's the same darn plan to go use the index on last name and to then do the bookmark lookup. So the fundamental problem that we have is that they optimized a statement which actually wasn't executed. Now the good news is, all you have to do is break this down into, let's say, a stored procedure that gets the member number with a recompile, or this one is with a wildcard, and this one is get member number without a wildcard. So I'm going to create 2 stored procedures to execute the 2 different blocks inside the stored procedure. I'm going to create those, and then I'll create a wrapper stored procedure that effectively does our conditional logic. If there's a wildcard, do the wildcard procedure. Otherwise, do the without wildcard procedure. And what will end up happening here is they won't step into a sub-procedure unless it gets executed, so it won't get optimized, which is good because it was actually unoptimal before. So the thing that's nice is now you can end up controlling your get member number with wildcard versus your get member number without wildcard. So simply put, let me do my last demo on this one. I can execute any combination of these, and they will all have 10 IOs, effective plans. Instead of the, 781 a moment ago, it's now only, I've got to scroll to it, 144. This one is 10. This last one, let's just go to the end, 144. And if I look at the plans of execution, I have the bookmark lookup, I have the table scan. If I scroll in here, I've got another bookmark lookup and another table scan. So the point was that when I broke that stored procedure down into smaller, more manageable chunks, you can control those chunks and set the recompilation on that much smaller chunk of your code. You get more control, and that allows you a lot better performance. So I think that's it for me. Am I done? We're done? Yay! Okay. I think I talked about 800 miles an hour.